So far we've looked at one example, and the example is the classic sphere. But it is the same rule set that works on any shape. So in this video, I'm going to go through simple and then increasingly complicated examples to show how these same rules apply in different scenarios. And when I was learning this stuff, it really only started making sense when I saw it repeated over and over. So hopefully that's what this video is going to do. Just going to show you it through enough different repetitions that it'll start to sink in. So let's talk about how we would approach something like this rectangle here. This is not a sphere, so it's going to be a little different than that last diagram we discussed. But the fact is, you still have a terminator. This is the point at which you go from light to dark. And here it's just going to be these faces of the cube that are not facing the light source. So if we can say this is our terminator, then we need to be able to determine where is the cast shadow. Because really, I think a great first step in this whole process is to be able to cast your shadow. Really, to do this, we only need a few landmarks. We need to know these corners and to be able to project them down onto the ground plane. And then all you have to do is connect the dots and you get the shadow shape. Now, if this seems immediately too challenging for you, my guess is it means you don't have a great grasp on linear perspective. Now, in the store, there's a series all about linear perspective, and I wouldn't exclusively call this a prerequisite, but it's definitely going to help. Because a lot of this drawing from your imagination really does rely on perspective. So here in this case, I was able to imagine where the ground plane was in order to know how far to project these lines. And if you can't really picture the ground plane, then you can't do this step. So once you've filled in this shape, then you might add a little bounce light back into the cube. But really that's just polish. The crucial first step here is to be able to identify where's the terminator. In this case, it's a pretty straight, obvious line, and that's based on the light angle. And then once you've found the terminator, you extend some points, and then you have your shadow shape. Okay, this next example does not have any corners, so how do we know where to cast our shadow from? Well, first let's think about it in terms of a top view. And if we picture this from straight down, it becomes a little bit like that sphere. So based on the light angle, we know that the very front of this cylinder is going to be the brightest. Then it's going to get dimmer and dimmer and dimmer as it rolls away across the form. And then here at the apex, we have the terminator. So the back half of this cylinder is essentially totally in shadow. Well, I'm going to draw that in my form here on 3D space. And now, once again, I need to know where the ground plane is. And this is where linear perspective comes into play. But then once I do that, I can just pull some lines that are parallel to the light direction. And then just find a few points on the edge of the terminator. And all I do is intersect those lines parallel to the light source from the terminator to the ground plane. And then I just have a connect the dots down here. So I'll pull lines that start from the terminator at the bottom of the object, and then pull towards those new points that I found on the ground plane. And then at this point, I know that those sort of 3 points that I projected are going to end in a rounded top because this is a cylinder. And then I can just erase away all those guidelines that I had because I don't really need those anymore at this point. And then it's just a matter of filling in the shadow shape. And if I want to, I can go ahead and add a little polish. So you could think of it as a totally black shadow shape for simplicity, or here I'm sort of rounding out the form and adding a little bit of reflected light back in. But again, this is just polish. The crucial thing to understand here is, can you look at the angle of the light, figure out how to project a cast shadow from the edge of the terminator onto the ground plane. Okay, let's go ahead and do the same thing here, but this time we are going to do a sphere that is not perpendicular to the camera. So really the crucial thing here is to figure out where is that terminator. And the way I like to think about it is almost like a cross section. Again, this is a bit of linear perspective, but what I'm doing is envisioning a disk that would be almost like the equator of this object. Now, unlike the Earth, this is not the equator that's perfectly horizontal. Here it is an equator that is pointing exactly at the light source. Now, this is not physically in your object. As you see here, I'm erasing that back of the object. But what that cross-section gives me is the shape of the terminator. Because really all we're doing here is the exact same thing as the side view that we thought of before. The light angle comes in at one direction, and then essentially 90 degrees to that direction is going to tell us where our Terminator is. So you're envisioning this diagram, we just happen to be doing it in three-dimensional space. So again, this is where understanding linear perspective is just going to help you imagine this a little bit more easily. But then once we've determined where the Terminator is, we can fill in everything below it, and that gives us our form shadow. And here I've sort of softened up that transition a little bit, but you could leave it as razor sharp as you want. That's really just a question of what kind of light source is casting the shadow. Now I take some parallel lines and pull them from the edge of the Terminator, and then I'm going to throw in sort of a quick ground plane just so I can help visualize this a little bit better. And then I will connect the points where those parallel lines connect with the ground plane, refine it a little bit, and this is going to give me the shape of my shadow. So once again, how I decide to fill in this shadow and how much I want to refine afterwards is not as important right now. The important part is being able to visualize that set of parallel lines that go from the edge of the Terminator and then intersect with the ground plane. This is a little hard to wrap your head around at first, but it is just the crucial thing to make this technique work. Because the rendering part, that's easy. You know how to mix paint, you know how to make careful edges, but what you may not know how to do is place a shadow. And all the rendering in the world is not going to fix a incorrectly placed shadow. But speaking of which, when I sort of resolve this at the end here, I recognize that my Terminator is actually a little bit low. And so in the sort of polished rendering I do here, I raise it up a bit, and then it squares better with my cast shadow. All right, let's go ahead and try this one more time with the cylindrical pole. This time we've got a little different direction for the light source, so the shadow is going to be cast backwards into the distance. So the first step in trying to figure out how to project my cast shadow is deciding where my Terminator is. And here in the little diagram I've included in the top view, you can see that the Terminator here is only going to really be visible on one side of the form. But once you find where that Terminator is, just start pulling lines on the ground plane, erase away what you don't need, and then we're going to connect those lines from the parallel lines at the top of the form. You know, and this is a real world thing that you can observe. If you go outside on a sunny day and there's a telephone pole casting a shadow onto the road, you can look at where is the end of the cast shadow and then draw an imaginary line to the tip of the telephone pole. And then if you just keep extending that line, eventually you'll hit the sun. So this is not some arbitrary rule. This is just how light works in the real world. And then of course the rendering part here is pretty self-explanatory. You erase away your guides, you fill in the cast shadow and the form shadow. And then if you want to lighten up the form shadow a little bit to represent bounced light, that's fine. Again, this polished stuff I'll leave to your own devices. I'm just going to show a little bit here. But the really important part is finding that Terminator and then correctly projecting the cast shadow. Okay, hopefully this is starting to sink in a little bit. So let's take the difficulty up one level, and instead of having a ground plane to cast a shadow on, we're going to have another object. So in this case, we have a floating cylinder casting a shadow straight down onto a cube and a ground plane. Now this might be a little harder to see in the real world, although think of anything. Think of power lines hanging over the road. Same deal. So just like before, the first step is going to be find the Terminator on the cylinder. Now in this case, the light is coming from absolutely straight overhead as if it were noon. So the Terminator is going to be about halfway down the form. The top half is going to be light, the bottom half is going to be dark. And this is going to give us the edge from which we are going to pull these vertical lines. Now, in this case, vertical lines are parallel to the light source. So as you're pulling these lines straight down, you're going to have to know where is the ground plane. Again, this is sort of a linear perspective thing, but where they hit the ground is going to be the edge of the cast shadow. And then we'll just begin to extend these lines as if they were following along the surface. So it will extend along the ground plane until it hits the cube, and then it's going to go straight up the face of the cube. And then at this point, it will go across the top of the cube, staying sort of parallel with the lines of the cube. And then to figure out where it extends to beyond the cube, I'll just pull some sort of parallel lines along the ground plane and then drop my projection line straight down from the edge of the Terminator to find that intersection. So here I've got my cast shadow shape. I mean, how cool is that? I did not have to look at any reference. All I did was follow a few rules, understand a little bit about perspective, and I can cast a realistic imaginary shadow on an imaginary box. I just think that's awesome. Again, the rest of the polish you do beyond this point is totally up to you, but figuring out where to project that shadow, that's the tricky part. Okay, got that? Well, let's take it up one step more difficult. Now, really, the rule here is that shadows do not multiply together. When you have two different shadows, in this case, a rectangle casting a shadow on top of a sphere, and the sphere has its own form shadow, those two just sort of get welded together and make a single shape. But a cast shadow is generally going to have a harder edge, but a form shadow like this sphere is probably going to have a softer transition. So the end result here of the two added together is a sharp edge and a soft edge. So the way I like to do these generally is to start by rendering the form shadow on the sphere here. And that is going to remain untouched by the next results I do. Everything else is going to be added to that. So now it's a matter of pulling lines parallel to the light source to project my shadow edges. And since this is a nice rectangle, I can just pull them from the four corners, intersect them with the ground plane, and erase the extras. And so once again, here I have the cast shadow shape on the ground. But now the question is, well, where is the cast shadow on the sphere? And just like in a previous example, this is all a matter of being able to picture a cross section, being able to imagine a contour line being drawn across the surface of this form, almost like a longitude or latitude line on a globe. And it's just going to be, where does the shadow edge intersect with the surface of the sphere, and then draw one of those lines around the edge. And if you get that contour incorrect, it's going to mess with the perception of the sphere's form. The cast shadow edge here is really going to help explain the shape of the sphere, so getting it right is pretty important. And then you've got your shadow shape. So you're going to fill in the cast shadow pretty flat. And then here I just want to make sure the values are going to match up between the old form shadow I had on the sphere with the new cast shadow from the rectangle. But the results you see here are something you're going to start seeing a lot of, which is a hard cast shadow transitioning into a soft form shadow. So let's go ahead and try a similar example here. We have the cube from before, and we're going to go ahead and add in a cylinder laying next to it on the ground. And the way I like to think about this first is, well, what is the form shadow going to be on the cylinder? Because no matter what shadow gets cast on top of a form shadow, you always have a form shadow. So for me, that's a great place to start. So I'll start by thinking about, where is the Terminator? Again, this is where the light becomes parallel to the surface, and I'll draw a line there. And then this is really that crucial thing. Once I know where the Terminator is, I know that everything below it is form shadow. And then I'm also going to know how to project that cast shadow from the edge of the Terminator. So for me, the sort of rendering shorthand for this is fill it all in with a solid tone, as if there were no bounce light at all. And then think about where there's going to be bounce light. And then I'm going to put in a little bit of an occlusion shadow down here where it's sort of the deepest crevice. So that's going to be a little bit darker than the rest of the cast shadow. But really, at this point, this is just being sort of fussy, because you'll notice that I have not yet included a crucial piece, which is the cast shadow from the rectangle that is being cast on top of the cylinder. Because really, the form shadow is almost separate from the cast shadow. So I can go ahead and do the form shadow all the way first, and then do my cast shadow. So just like before, I'm going to go from the corners here, because that's the Terminator, and project parallel to the light direction. And then when it intersects with this cylinder, it is going to sort of curve around the contour. So once again, this involves me sort of imagining cross sections of the cylinder to help guide the way that I draw this projected cast shadow. If I get this contour wrong, it's really going to mess up the form. But if I get it right, it's going to help really accentuate the shape of the cylinder. And then once I've traced my outlines, I can go ahead and fill it in, and the rest is pretty basic. All right, next we are going to take a look at a compound object. Because the world is not made of primitives, there are sometimes objects that have sort of two shapes welded together. And in this case, we have a simple sphere with a disc protruding from the top. And let's take a look at what we've got here before we go ahead and create it ourselves. We have a standard rendering as if you'd imagine the normal sphere, but then the disc has its own terminator, it has its own mini form shadow, and it also is casting a small shadow. So the way I'd approach this would be just like before. I'd start with the terminator, I'd fill in the form shadow, and then I would project my cast shadow. Although in this case, it's casting a shadow on itself. It doesn't even get near the ground plane because it's such a short disk. But the rules are all the same. In this case, you can think of the sphere as the ground plane. So to continue this thought experiment, what if instead of a disk, it was actually a tall rod that was extending out of the sphere? My first step would be to add the terminator, which here is just like rendering a normal cylinder. And then once I have a general sense of where the terminator is, it becomes a question of where is the cast shadow. Now before with the disc, the cast shadow was very small. But now, since this rod is much longer, the cast shadow is also going to be much longer. So first off, I am going to pull some lines along the form of the sphere. Again, this is like imagining longitude or latitude lines. You're just drawing contours of the object. And then I can fill that in with a flat value because this is the hard-edged cast shadow. But in this case, it is going to be long enough that it actually extends off of the form and onto the ground plane. So to figure out where that is exactly, once again, I'll just draw lines that are parallel to the light source, starting at the terminator and then intersecting with the ground plane. So as you're starting to see here, I'm just doing the same rules over and over in different combinations. What starts to happen is you'll be able to look at a form and sort of break it down into geometric shapes in your mind's eye. And then you'll start to see, where is a hard edge? Well, that's probably because it's a cast shadow. Where's a soft edge? Well, that might be where a form shadow is showing that a surface is rounding around in space and turning away from the light source. But I gotta say, graphically, cast shadows are really great. Here in this example, you can see that a chair just gives you more information when you can look at its cast shadow. It's almost like getting a second view of the object in a single image. Your brain really just does a great job putting together that information to give you a fuller picture. Another great example would be if you had something like this sort of flat, generic, bumpy outdoor scene, like a field with rocks in it. But then if you put a bridge over this gap, all of a sudden the cast shadow tells you a lot about that field. You get almost like a cross contour line just drawn from that shadow that gives you a great sense of shape. Now the ground that had sort of ambiguous bumps before has a really clear contour. Another time cast shadows are useful is when you're looking from a sort of high camera angle and you can't see much of an object. All of a sudden the cast shadow tells you a lot more about the object's form than the form itself. Of course, in an example like this, the time of day does matter. This same shot at high noon would not give you much info. So we can agree that cast shadows are very important. They really help set the scene and help explain form. But the learning curve can be kind of challenging to figure out how to project these yourself. But I kind of like this stuff because it gives you almost a formula to just render out a scene based on simple rules. So by now, the homework for this chapter should come as no surprise. I'm going to give you a very straightforward light, which is a directional light just like these examples. I'm also going to include the form, and I've also included a ground plane if you're having trouble picturing the sort of ground grid. But what you're supposed to do here is to fill in the form shadow and the cast shadow. Now, as far as how you render the shadow, well, that's up to you. If you don't want to do any reflected light, it doesn't matter to me. Really, it's a question of can you find the terminator? Can you project the cast shadow? Good luck with this. This is tough, but it is really going to improve your drawing.